Today we are going to discuss about function. Now let's see the definition. Definition of function, it is a special type of relation. So it is basically a relation, but it's a little different approach is there to the relation. Then relation becomes function. What is that different? What is that special about it? We will learn in this further explanation. A relation from f from means function. A relation will be a function from a set A to a set B is said to be a function if every element of set A has one and only one image. This is important. Or unique image in set B. In other words, function f is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no two distinct order pairs in F have the same first element. Means there can be one to many relation is possible, but many to one relation is not possible. Okay, in short, you can understand like that many to one is possible, but one to many is not possible. One to many means there is no unique image, one and many, but many to one is possible. So many to one means unique image is possible. The function f from A to B is denoted by f such that A arrow B. Okay, now see, a relation is a function if every element of first set has an image. Every element of first set has only one image. Here in this figure, both conditions are satisfied, so this relation is a function. See, 2, 5, 8, 11, 14 and 17 all are mapping to 1. Means many to 1 is possible, but one to many is not possible. So the relation which is having each element in set 1 has unique element or image in set B, then that type of relation is called a function. Okay, so many to one is possible, but one to many is not possible. If f is a function from A to B and AB, ordered pair AB belongs to f, then f of A will be equal to B. Means B is nothing but f of A, means function of A. B is called the image of A under F and A is called the pre-image of B under F. So there is no problem in that. Now one example. Let n be the set of natural numbers and relation R be defined as order pair AB such that B is equal to A square and A and B are member of n. State whether R is a relation which is a function or not. Means it is a relation, but whether it is a function or not. So see, explanation, solution. From the relation R, which is like this order pair AB such that B is equal to A square and AB belongs to n. Here for every value of natural number there is one image, one and only one image. Okay. For example, if you take A as 1, then B will be what? 1 square, that is 1. If you take A as 2, then B will be A square, that is 4, and so on. Moreover, if you take A as minus 1, then also B is 1. Means 1 and minus 1 have the same image 1. That is many to 1 is possible, but 1 to many is not possible. So here is the case of many to 1. Means only one image is there. So this relation is a function. Next, come to the exercise 2.3. Which of the following relation are functions? Give reasons if it is a function. Determine its domain and range. Now see, this is a Cartesian product of a set A and B, like 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. Similarly, second part is there 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7, 1, 3, 1, 5, 2, 5. So let us see first part. This is your Cartesian product, means there is a relation basically. Here first image 2, 5, 8, 11, 14 and 17 are having their unique images because 2 is having 1, 5 is having 1, means this is kind of many one. 2 and 5 in the first set has the same image in the second. 8 also have same image, 11 also have same image, 14 also have same image, 17 also have same image. So previously I have shown in the example, this is the case like that. So your domain is the first element 2, 5, 8, 11, 14 and 17 and range is 1. So this is a function. This relation is a function because unique image is there for every element in the first set. Now second part, 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. So here 2, 4, 6, 8, 10, 12 and 14 are the elements of the domain of the given relation having their unique images. Means each element has the unique image. Okay, so this is also a function. And domain first elements and range are the second elements of that relation. Now 1, 3, 1, 5, 2, 5. It is seen that same first element, one has two different images, 3 and 5. Okay, you can see first element has two images, 1 and 3 and 1 and 5. So many to one is not possible. So this is not a function. Come to the next question. Find the domain and range of the following real function. Fx is mod of x with minus sign. Fx is square root of 9 minus x square. Now solution, let us see. Given fx is minus of mod x, where x belongs to R. We know that about mod x, that it will be x if it is greater or equal to 0. It will be minus x if it is negative. So here in this case, fx will be just reverse of this because there is a negative sign over here. So negative of mod x will be, for greater or equal to 0, it will be minus x. And for less than 0, it will be x. Now see, as fx is defined for x belongs to R, that is real numbers, the domain of f is R. Okay, so x is belonging to R, so domain of f is real numbers. It is also seen that range of fx is equal to minus of mod x is all real numbers except positive real numbers. Means why it is not positive? You can see here. When you are having x is greater than 0, then the value is minus x, means a negative number will be the answer. When x is negative, then no change, means again a negative number. So both cases you are having a negative number. So we are saying that real numbers, all the real numbers except positive real numbers. So range of f is given by this closed bracket from the right side, including 0 and minus infinity from the left side. So minus infinity to 0 will be the range of this function. Clear? Now second, fx square root of 9 minus x square. As square root of 9 minus x square is defined for all real numbers that are greater than or equal to minus 3 and less than or equal to plus 3. Why are saying like that? See, if it is minus 3, then 9 minus 9, 0. Minus 3 square, 9. If it is 3, then 3 square, so 9 minus 9, 0. And within that, minus 3 and 3 will give you a positive value, then only you can find the square root. Otherwise, you cannot find the square root. So we are limiting it x as minus 3, all the real numbers between minus 3 and plus 3. So, because 9 minus x square to be greater or equal to 0. So the domain of fx will be, x will be such that it will be greater or equal to minus 3 and less equal to 3. So this is the closed interval minus 3 and 3. Now for the range. For any value of x in this range, the value of fx will lie between 0 and 3. Okay? Because when you take any number, suppose it is 2. So 9 minus 4, that is 5. Square root of 5. So it is always 2 point something, so 0 and 3. So all the numbers which is between minus 3 and this 3 will give you number between 0 and 3 when you will solve this one. Okay, so this will be the range. Range will be what? X such that x will be greater or equal to 0 and less equal to 3. So closed interval 0 and 3. Next. Question number 3. A function f is defined by fx to x minus 5. Write down the values of f0, f7, f minus 3. It's very simple. You have to put the values in place of x, you have to write 0 and find the values. So 2 into 0 minus 5, that is 0 minus 5, so minus 5. For f7, 2 into 7 minus 5, 14 minus 5, 9. For f of minus 3, 2 into minus 3, minus 5, minus 6, minus 5, minus 11. So very simple question. Fourth number, the function T, which maps temperature in degree Celsius into temperature in degree Fahrenheit, is defined by T of C is equal to 9C by 5 plus 32. And then you have to find T0, T28, t minus 10. And the value of c when tc is 2 and 2. So let us see. Very simple, it is like third only. Given function at tc 9c upon 5 plus 32. T0 will be 9 into 0 divided by 5 plus 32. So you will get 32. Similarly, T18, 9 into 28 upon 5 plus 32. And you will get this one. So similarly for now minus 10, 9 into minus 10 upon 5 plus 32. After solving, you will get this. Now TC is 2 and 2. Means this 2 and 2 answer is given. You have to find C. So 9C upon 5 plus 32. So after simplification, 9C upon 5 will be 2 and 2 minus 32. This will give you 180. So cross multiply and find the value of C. You will get 100. Okay. Question number 5. Find the range of each of the functions fx 2 minus 3x, where x is greater than 0, fx x square plus 2, where x is a real number, fx x is a real number. Now question first part. Given fx is 2 minus 3x and x belongs to R, x is greater than 0. We have x is greater than 0, so 3x will be greater than 0. So negative sign to both sides multiplies and then this relation will change. Minus 3x will be less than 0 now. And add 2 to both sides. So 2 minus 3x is less than 2. Therefore, the value of 2 minus 3x is less than 2. So range will be what? Minus infinity to 2. Okay. This way you have to find the range. Now question number 2, which is fx equal to x square plus 2. And x is a real number. So whenever you take, this is one table. If you put x equal to 0, then you will get 2. If you put x equal to plus minus 0.3, you will get 2.09. Plus minus 0.8, you will get 2.64. Plus minus 1, 3. Plus minus 2, 6. Plus minus 3, 11. So in this way, you can observe that range of f is the set of all real numbers greater than 2. Okay. All the real numbers greater than 2. And reason is what? So you will write that 2 to infinity. Closed interval 2 up to infinity. How you will explain? See. You know that x square is greater or equal to 0. So x square plus 2 will also be greater or equal to 2 because we will add 2 to both sides. Therefore, the value of x square plus 2 is always greater than or equal to 2 for x is a real number. So your range will be closed interval 2 to infinity. Infinity not included, okay? So it is open from the right side. Now third is fx is x. So fx is x is a real number. Clearly the range of f is the set of all real numbers. So range of f will be R. Thank you.